Okay, thanks for coming. Welcome all to Coronavirus Special. We're going to call this talk Unlearning Elixir. This is me. That's my email address. The reason why is because how many people actually ever gone to a talk where like a bunch of URLs and stuff go by and resources and people tell you things and you're typing or writing furiously and then it just disappears? Right? All of you? Great. So I actually hate that stuff when it happens. By the way, I don't know. Actually, Bruce, will you stand up? So this is Bruce Tate. This is the person who actually taught me Elixir. Right? He's under the bus again. And the reason I'm making him stand up is because Bruce has challenged me to curse less in my talks. Now, there does exist a version of this.
So we can put you on YouTube, man.
Right. There is a version of this talk on YouTube that apparently is behind some sort of NC-17 wall. Because apparently somebody says that I said something about shore leave and sailors cursing. Whatever. Anyway, so I'm going to try not to do that. But the point is my email address is up there so that you guys can send me an email and I will send you all the links in a PDF from this talk and a bunch of stuff that didn't actually quite fit in. So like the research notes and any of the links about that stuff are actually there. Drop me an email and say, hey, CodeBeamFF, the Unlearning Elixir talks, and I will send you a PDF that it's basically all the stuff from my org file. I just do a dump into a PDF. All right? We good? So now you actually can pay attention. You don't have to be like scribbling notes. That was actually the original title of this talk, which, because of course, apparently these conferences are family oriented, we can't do that, right? So, but since all of you are laughing, that means all of you have had some of that agony, right? Like functional is not easy. So one of the things I want to know is how many people in here actually write a functional language like as their day job? Holy crap. I'm used to giving this talk to like rooms of like Ruby developers and like JavaScript people. And the JavaScript people just look like they're filled with rage. What's up? Okay, how many people here do more than one language, like they're a polyglot?
Same time?
I always type differently so my left hand doesn't know the language my right hand is programming in. It's like we can hack, we can pair on this. It's hacking. Let's get on the same keyboard. Okay, I can skip over a lot of this stuff then, because normally in this slide, I use it to actually ease people who wander in to realize that they're walking to a functional programming talk that weren't talking about how they're going to do npm install and get it to work, right? First languages. How many people here had a C or procedural language as their first language? My first language is assembler, so I'm not even sure it was really procedural. Okay, anybody have a functional language as their first language? Really? How would you get so lucky? Racket. Yeah. Actually, we have Racket Weekend showing up later in this slide talk, I think, somewhere. So yeah, we're going to talk about some Racket. You're lucky. She's better than the rest of us. What's that? Well, way to anticipate the slide. How many people had a functional language as their second language? Or somewhere, 3, 4 languages? Anyone? Somewhere? Okay. All right. This is going to be interesting. Anybody know who this guy is? Oh, shout it out. This is an interactive presentation. FEYNMAN, that's right. Mr. FEYNMAN, he's actually this guy who did something about physics, got some Nobel Prize, quantum electrochromodynamics, whatever. Anyway, so what you don't know is that it turns out that he actually had an incredible technique for learning something. He was actually famous for being a polymath of ultimate type, including playing the bongos. Right? And if you ever want to read an amazing book back-to-back, read either Genius and then Surely You're Joking, Mr. FEYNMAN, and you'll realize that you're just not nearly smart enough to be on this planet with people like this. But he actually did say there's a great pattern to learning and teaching something. And it's not as intuitive as you would think, because the first step is, of course, we study something, right? The second thing we actually have to do is teach it. Okay, so none of you are actually shocked or walking out of the room, so let me explain this to you. I want to be an open heart surgeon, so I read a book on open heart surgery. Now I'm actually going to teach you to be an open heart surgeon. Right? Sounds a little counterintuitive, doesn't it?
Actually, their rules usually are watch one. It's the third one. So 3 teaches a third one. Watch one, do one, teach one.
Yeah, that's backwards, right? Do one, watch one. Okay, do one.
Watch one, do one.
Well, at least if you're teaching before you do one, can the other person go like, are you sure that's right? Anyway, so understand, right? You have to process what you're actually learning. And the funny thing is what you're doing when you're teaching is you're actually using it to figure out what you understand and what you don't. You're actually sort of It's almost like using that poor person as a rubber duck for your own ends, right? And then you've got to wash, rinse, repeat. And so if you do that, what ends up happening is you can actually accelerate the cycle of learning. So the funny thing about the FEYNMAN technique for learning something is that you don't wait to become an expert before you teach it. And it's really kind of important because has anybody actually ever tried to learn something from an expert? It doesn't work very well, right? Because Bruce has a lot of great stuff about this, like the Dreyfus model, but in short, experts can't teach beginners, right? Oh, sweet. The ultimate tool for debugging. We all have had this, right? I think everybody has one of these sitting somewhere. So, where are we headed today? We're going to talk about biases, we're going to talk about your brains, and then we're actually going to talk about how you can actually trick these things into getting you the basic skills to getting a functional language, right? So, things else you need to know about me, time I've wasted. The reason this is important is because the background of how people learn languages is super important. If I learn C++ first and then I come to some functional language, I'm going to have a whole bunch of baggage and I'm going to be telling you that your syntax in Erlang is crazy. You've got these curly braces everywhere. It's insane. Everybody knows that the only thing you should have is 22 angle brackets next to each other while you have a template that's partially specified. Anybody written Perl? Anybody willing to admit that they writ Perl? Okay, Perl CGI, right? So my background was mostly in C-based languages and assembler. So I started off as an embedded systems programmer, and I actually came to higher level languages like C much later. So the problem we're solving is actually, as it turns out, your brains are not designed to learn things. And so before you can learn something else, you've got to know how your brain's going to work and how it's going to actually work against you, right? Now the next part is going to be like, notice that it's actually not a curse word, Bruce. I mean, this is actually something else we're going to talk about. We're going to talk about the biases that your brain puts in there. And we're going to give you that moment like, have you ever had somebody who's actually been like blah, 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 blah. You spend 3 hours debugging something, and then they say, or you could just put the semicolon here. What? That's that moment. So we're going to talk about how do we get to those moments faster, because like it or not, those moments of actual extreme frustration followed by a small piece of enlightenment and possibly murder of the pair are super important. So how do we maximize those? And then guru level enlightenment, right? That's the point at which you're like, oh, okay, and you can start to actually get this stuff turning over in your brain. So how did I learn to love Lambda languages, especially if I started off in assembler and used to laugh at people writing C? As it turns out, oh, I want to point out something here. That is not assignment. Really? I thought that would play for more laughs in this group. God, man, okay.
You just read it that way to begin with.
Okay, this is actually why I got into programming. I assumed that if I was a programmer, I was going to be this guy, sitting at some table somewhere, being suave, writing robots, doing all this crazy, crazy stuff, right? So this is what happened when I first dove into functional programming. People handed me a book on category theory, and they said, oh, just read this book on category theory, it'll be fine, right? Now, anybody here actually know, this might happen here. Anybody here actually a category theory or a PhD researcher in this stuff? Because, good, because I'm going to mock all of you. You shouldn't have to have a PhD in applied or abstract mathematics to write a piece of software, right? It might be applicable, but it shouldn't be a requirement or a prerequisite, right? So this is basically my first experience with functional programming languages. I asked some friends for help. And this is pretty much where I ended up, right? Because hello world requires a monad sometimes just because it does. Okay. So given that most people who try and use a functional language end up looking like this, what's going on, right? Why are we keeping doing this to ourselves? If functional languages are so bad, why are they so painful to learn? What's the issue here? Why is it that everybody and their mother has a Node application, but nobody is actually writing F# or Haskell or Erlang or Elixir, right? Anyone? I don't know. Well, so I have a theory. And programmers are a very particular type of lazy. Okay, I'm going to start a holy war here. We might have to separate the room. How many people here use VI? How many people here use Emacs? Don't attack the people who raise their hand. Hey, man. That's right. Good looking out. 2 of us. Right? Any other editors? Atom, Sublime, VS Code. No, it's okay. You can be proud about it. It's okay to say we are in an age of where we can choose our pronouns and we can choose to use a Microsoft product. Right? So it's funny because I will see somebody spend 2 friggin' hours to get the parent matching working inside of a nihilist program, or God forbid, writing Vim script. And in fact, T. Pope used to work for us a long time ago. I've seen T. Pope write Vim script, and he wrote Vim script so you don't have to. So you will spend hours and hours and hours getting that stuff working, right? And yet they won't learn a new language. It's like, no, that's too much work, right? Like think about this. How many people here have actually substituted and tried things like hack versus fur code versus nerd font versus like, I don't know, the kerning that's almost 2 points of additional kerning there, right? So programmers are a very bizarre type of lazy, right? We will spend hours and hours and hours and hours optimizing itty little bitty things, but we won't spend something that might change the paradigms about the way we do our work. It's just, I don't know why that is. But the other thing we have fighting against us is history. All of us, like it or not, actually have this image that the computers and the systems we use were built by these omniscient engineers who had our best interests at heart. That is completely not true, right? As anybody who's actually ever written any x86 code can tell you, right? Protected mode, extended mode, register what, EDX what? Like, no, computers are not your friend, right? As it turns out, they were a series of compromises, or as somebody said, there was a tweet that somebody told me about actually at Lone Star this past weekend, and where they said, yeah, programming is all great until you find out that the internet is made out of goblins and peanut butter, right? So there's a lot of history we're fighting with these languages, right? C, the syntax, like C was designed because it needed to fit into a small memory footprint, not because they actually wanted to pick and make a small compact language, right? There were practical reasons there. So here's an experiment for us. Randomly sample a word of 3 or more letters from an English text. Is it more likely that A, the word starts with an R, like rope, or B, that R is its 3rd letter, like park? Okay, this is a timed exercise. How many people say A? How many people say B? How many people think this is a trick question and there's no right answer? That's good, I'm tricky. This is a smarter group than most. As it turns out, you guys are totally blowing the curve. So the right answer is B. And this is actually something, has anybody ever heard of a book called Thinking Fast and Slow? Kahneman and Tversky, they're basically behavioral economists that basically prove we're all really, really stupid and that there is no invisible hand actually guiding the economy. It's just idiots all the way down. So
you wrote the jacket, the flap copy, right?
yeah, I did. I really did. And this is actually what's called an availability bias heuristic, right? What they found out is that people use heuristics as shorthand, and the problem with heuristics is that they're normally, or can be, often wrong. A heuristic is anything. It's a mental shortcut that we use to do something. Kind of like you can almost always make a right on red until that one time you go to make a right on red and somebody T-bones you, right? And you're like, where did that come from? It's because your brain short circuits it. Our brain has to do a lot of processing and it actually has to do a lot of work. So it basically comes up with shortcuts, right? Well, these shortcuts lead us to cognitive biases. And remember, we don't need to write these links down because you can always send me an email and I will send them to you. But this one's really important because that guy down there actually does a type of research on, and I want to make sure I read this correctly, the systematic experimental study of reproducible errors of human reasoning and what these errors reveal about the underlying mental processes is known as heuristics and biases program in cognitive psychology. Okay, really long, right? You're like, so? This program has made discoveries highly relevant to assessors of global catastrophic risks. As in, he studies how our brains go wrong when we actually the fate of the world hangs in the balance. And ironically enough, I just summoned up a coronavirus for this conference to make the point. Right? So people underestimate the availability and for instance, of how they're going to get coronavirus. They'll cross the street smoking a cigarette and then they won't shake your hand. Right? Which one's going to kill you faster? So these are biases that we have. And so the funny thing is, as programmers, if you think you don't have them, you are deeply, deeply wrong. Because one of the things your first language did, or your second, or writing a bunch of C or Python, is give you a whole bunch of biases that are ingrained in your brain and make it very hard for your brain to see the pattern in something else. Right? So this is the person that you can blame if you can't figure out how to learn a functional language. It's not your fault. If you had learned, if you were lucky enough to learn Racket first, you can just be like, I don't see what the big chill is, guys. It's not that hard, right? But for the rest of us, we actually have brains that aren't doing this so well. So one of the first tasks you actually have to set yourself before you want to learn a language is you've got to build a new mental model about what that functional language is going to do, right? So first thing is you got to forget what you know, right? There's actually, it's really funny, I believe you just gave a talk about this. There's the Dreyfus model of learning, but Dave Thomas talks about this a lot. But there are stages you go through learning, but the first one is when anytime you learn a new language or a new platform, you've got to go back to zero. Has anybody actually ever installed a different version of Node? Right? Node 8, Node 9, how different could it be? Oops, right? So you've got to do this a lot when you do this. The second thing to remember is garbage in, how does this finish? That's right, unless you have a monadic function, in which case nothing comes out. So you know how often I can actually get a chuckle out of a monad joke? That is probably the biggest laugh, right? It's usually singular, but be that as it may, right? Garbage in, garbage out. So you've got to do good reps in your training. You've got to find good resources to teach yourself how to write functional programs. If you don't, you're basically going to be writing procedural programs in a functional language. And how many people have ever debugged or seen code like that? How many have written it? Okay, so another thing is you got to learn how you learn, right? Not everybody learns the same way. Some of us can read books, some of us can learn from pairing, some of us can watch videos. But if you don't know how you're going to learn, you will actually never get through this and you'll be frustrated. So picking up on what works for you is super important because I might tell you to go read this great book I loved and it's not gonna stick. And then finally, master the basics. And one of the things, there's a guy I really enjoyed, I know him for a long time, but one of the things he always said is there are no advanced techniques, only a rigorous mastery of the basics, right? And so the idea there is that what you think of as something that's super advanced isn't. It's actually just somebody who understands things so well that they can make those basic things look magical, right? And finally, crawl, walk, run. Do not start with an embedded system made in Haskell that's parsing your own data files as your first Haskell program, right? Maybe your second. So, and then finally give yourself time to do this stuff. It takes a long time to actually change your brain. You're actually changing new neural pathways. And your brain has a bunch of heuristics about how programs are built and written in function. Functional programming breaks them. So I like to call this 6-minute apps for Lambda languages. First off, you got to join AA. And by AA, I mean that you have to have affordances and abstractions. Affordance is something that comes from design thinking, and it's kind of like this. Has anybody ever seen a door that you go up to and it has a pull handle on it, and then when you pull it, it just doesn't go anywhere because it's a push door? Aside from the fact that there's a special place in Hades for the people who do that on doors, that's called an affordance, right? It gives you a visual indication of how the door should work. And the problem is when the affordances don't match the function, when they don't match up, you get Middlevale School for the Gifted, right? You're pushing on the door. And the abstractions are important because you need to understand what your language provides abstractions and what it doesn't. Like, for instance, Go or some other languages provide things that abstract away threads or threading models, right? C actually provides an abstraction over a memory model or a machine memory model, right? And so if you pick a language or a tool that doesn't match the level of abstraction at which you're going to need to work, you're just adding additional sort of friction to the process of learning a new language. Make sense? All right. So the need to understand an abstraction is directly proportional to its power. That's the nice way to say it for your boss. And this is what I actually really think about it. This is what you say in your code review. The more useful the abstraction, the more astounding the bug. So what do I mean by this? Anybody here ever written a Rails app? It's OK. I think we all been there, right? Anybody ever here had an n+1 query problem in a Rails app because of active record? Right? We've all done it. And that's because one of the things that DHH told us a long time ago is that you don't need to know SQL. Database, extract that stuff away. Dang, so hard. So, and the final thing to remember is just because you can, thank you, doesn't mean you should, right? Once again, picking on Node here, but you know, the shoe fits. So how do we learn Elixir? Well, the first thing you got to do is, well, learn Elixir. And so what do I mean by that? Don't learn this. Okay, so back in the day, I used to work at a company called Engine Yard. We were one of the first people to sort of really get into Ruby on Rails. We basically fell into it by accident. But we used to kind of have this joke. We would talk about the difference between Rails programmers and Ruby programmers, because we were all Ruby programmers, and then this Rails thing came along, and we could finally make money. Ruby programmers understood how Ruby worked, but Rails programmers didn't understand how Ruby worked. And so the second you put them into an IRB session, they would say something like, Monday.next, and not wonder, they'd be like, why does that not work? And you're like, whoa, okay, yeah, okay, what do I explain? Eigenclass, no, I can't explain to you why that doesn't work. So one of the things you've got to learn is oftentimes people say, don't teach me Elixir or teach me Phoenix, because I just want to build a web app. I just want to build a web app. So when you're doing that, stop that person. Stop the madness, learn Elixir first, because while you can absolutely write a Phoenix app without learning Elixir, understanding what it's doing is central to being able to be proficient with it. Right? And so that actually applies to almost everything, right? Okay, so here's the 10,000-pound gorilla in the room. Learn some Erlang, right? Elixir is built on Erlang, and there are oftentimes things that you will see in an Elixir app that people will be like, why on God's green earth? Oh, Erlang, because Erlang. And if you know Erlang, you become a much more proficient and effective Elixir developer, because you can pick a different level of abstraction in which to engage your problem at. And as it turns out, most of what we think of that's really neat stuff in Elixir is actually just Erlang, right? It's Erlang all the way down. It's processes all the way down. And you're also shortchanging yourself. Turns out Erlang's been around for a long time, and there are lots of libraries on the beam that will actually help you or save you. Anybody ever had to parse a crypto cert? Yeah, you do that once, and you basically find some Erlang to do that for you, right? Because nobody actually wants to parse, what was it, the ASN1 format or whatever, PEM, I can't remember, X509 certs. Anyway, so learn Erlang. It'll help you, even just a little bit, right? This is what most people think when you tell them to learn Erlang, right? And if you remember, this comic was originally done for React, because if React, basically you had to write a MapReduce or actually query your database for a while. Yeah, notice it's censored. Still family friendly. For those in the back who can't see it, it says, so how do I query the database? And it says, it's not a database, it's a key value store. Okay, it's not a database. How do I query it? You write a distributed MapReduce function in Erlang. He says, did you just tell me to go F myself? I believe I did, Bob. Right? Here's another thing. Learning another Lambda language or another functional language is deeply helpful. Now, this is kind of counterintuitive. You're like, well, what? I should be concentrating on the one language that I have. Well, as it turns out, that if you can learn another language like Racket, I really like teaching people Racket because it's small, scheme, compact, really useful. You can do useful stuff with it. Lisp, Clojure, anything. F#, OCaml. By learning another language, what it forces you to do is it forces you to get out of thinking in a language-specific solution and learn the abstractions, right? It basically says, oh, an enumeration is an enumeration. Like if I call it an enum in Ruby, it's not that different than an enum in Elixir or in something else, right? And when you start thinking differently about those types of problems, you've got to remember, this is one of my favorite quotes. Instead of asking, how do I do X in Elixir, ask how to solve Y. Right? Because one of the things you're inherently putting in there is an assumption that there's a solution that maps over to whatever it is you know. So that often comes out when people know C, for instance, and they start writing C-style functions in JavaScript. And there really isn't a real class sometimes there, right? There's a meta class, kind of, sort of, maybe prototype, kind of, well, sort of, we mocked it, it's an object model, kind of, sort of, right? So things don't quite work the same way. And once again, if you remember the previous rule about abstractions, the problem there is that you might get a solution, but it might surprise you in how it breaks or when it does, right? So think about your problem as actually, what's the Elixir-ish way to do this? Not necessarily, how do I do that, right? Because the answer might be, we just don't do that in Elixir, right? So here are 4 hard things that people always sort of struggle with. The syntax, right? People oftentimes actually get really caught up in the syntax that actually goes on in the Elixir and Erlang ecosystem, right? I still don't think Elixir or Erlang's pretty. I think it's functional, but I'm not really in love with it. I can write it, right? So it's okay. This is a safe space, right? Functions, right? People from procedural backgrounds have a really hard time thinking in the unit of a function. I mean, I still do sometimes. Like, you want to think about, well, I need to change this data, or I need to do this. Like, no. You don't need to write something that does that. You don't need a procedure that does that. You need to think about pipelines that transform data. And like, well, what's the difference? Well, there's a big difference in a functional language, right? Matching. Okay, how many people here grokked matching the first time they did it? Okay, genius, okay. What made it so easy? Did you have some other functional language?
I misunderstood grok. You meant how many people understood it.
Yeah.
I thought you were saying.
Okay. Great, it's good, because I was about to feel like my self-esteem just dropped like 10 points. I was about to be all like, oh, you too, Mr. Duck? Anyway, so matching, right? Matching is really hard because the funny thing is, once you have it though, how many people want to work in a language without it and who have basically gone to a language with pattern matching and then gone back to a language without it? It's painful, right? You're like, okay, so let me get this straight. I'm passing you 6 megs of data to get the one thing way down there and parsing the entire thing and loading a JSON library to do it? Good God, man, what's wrong with you, right? But once you actually understand in grok matching, which is super important in almost all functional languages, that pattern-based dispatch, you almost never want to live without it, right? Strings. If you haven't run into a bug in string in Erlang or Elixir yet, don't worry, you will, right? Erlang. Never get involved in a land war in Asia, and never actually talk to a presenter about the enumeration errors in his slides. All right, so enumerating things, right? People oftentimes forget about like writing enumerators and reducers. I would actually have put a reducer up there, like it's all reducers. That's actually something I stole from Bruce, but let's just start with enumeration first, and then we can get to reduction. But getting people to realize that they should treat things as an enumerable of something or nothing, whatever, it doesn't really matter, is a really hard concept, right? Because we want to have a Java array. We want to have something that's indexable. We want to have like something that has a finite size. And right, a lot of times in functional languages, we don't care, right? We just don't care. That's something that we don't need to be concerned with, right? So how do you write better Elixir? Anybody ever seen one of these? What is it?
CREDO.
Yes, CREDO. So there was actually an entire section here, and then I realized that the entire point of how to write better Elixir is actually install CREDO and use it. How many people here use CREDO on their projects? All the hands should be up in the air. How many people have Elixir in production that didn't use CREDO? Ah, man. So the thing is, CREDO is like one of the most helpful, nicest people who's a code reviewer. Imagine that person who's your pair who's reviewing your code that instead of just hitting no on your pull request and sending you the laughy smiley, actually sits over your shoulder and helps you write better code, right? CREDO, if you read it, it'll actually make you a better Elixir developer because you will learn and understand explicitly what is considered good Elixir, mediocre Elixir, and just don't do that, right? So CREDO is actually, I think it's like the best style guide ever because it's interactive. And you don't really have to do anything to basically get that feedback. For those of you who actually don't want to use CREDO, there are absolutely Elixir style guides that are out there. I'm a big fan of using a style guide and sticking with it, especially if you're coding with other people. But reading a style guide, it helps your brain understand the pattern and match on it so that you can actually get into the Elixir thing and start seeing, oh, that's what they want to mean. That's how pipeline should start. It should start with a bare value, and then it should go to a pipe. And it helps you understand why. Or not, and you understand, but you're consistent, right? Functions. People have a hard time with functions, but I actually like to think of them as Legos for your language, right? And there are only 3 real rules of functions, right? Functions themselves should be small, right? If you actually, how many people have ever seen like a functional method in like Elixir or Erlang that goes on for pages and pages? This is a code smell. Like, do not do this. If somebody is actually having a page of Elixir, they didn't know what they were doing either. Help them out, right? They should be explicit. Functions should be explicit in both what they do and what they do not. Like, and you can do that any number of ways, but the nice thing about it is like Elixir gives you a number of tools, everything from throwing an exception to not matching on a pattern to make sure that you're explicit about what you will take and what you will not, right? And then, they should be composable. Like, if you're writing functions that don't compose, it's like, man, come on, right? Like, what are you doing to me? Right? You're killing me, Smalls. Like, don't do this. Like, don't write functions that you can't actually use and build something else. In procedural languages, we have a tendency to think about that process and the whole thing, and we'll end up with these big, long methods, these master methods that do everything. Anybody here old enough to remember writing Windows applications? Like Windows and ATL, MFC applications? So just so you know, the original targeted method of writing a Windows application was to have a gigantic C switch statement with a case in the middle of your main run loop that dispatched directly to functions, such that the state of your program could be, depending on the order in which those messages are processed, the state of your program would change. What could go wrong, right? Says Clippy. Type specs. I'm not going to fight the religious war in this one. I think they're useful. Other people don't. You know, opinions may vary. If they're useful to you and they're useful to your team, use them. If they aren't, and it's actually keeping you from being able to learn the language because you're not quite sure what the type specs do or why dialyzer is neat, then forget about it and learn it later, right? Matching. It's one of the most important parts about learning something in Elixir. So here's what the definition that's taken from the docs actually says. Matching compares the term on the right to the pattern on the left. If the pattern doesn't exist, it binds the pattern on the left to the term on the right. That's super important because it means that you can put patterns and matching in places where you thought you could never put patterns and matching. And sometimes it can be both a boon to clean up code, or this is the devil's handbook, right? You can do some awful, awful things that are completely unintelligible to your fellow programmer. But understanding what it does is super important because it's not a quality, even though it looks like a quality because, you know what, you kind of let you rebind things. But this becomes super important when you start passing around closures, right? You need to understand what you're doing when you're matching, or sometimes when you have a weird like error, sometimes it spits out at you and it's like could not match, non-exhaustive match, and you're like, well, why not? You need to understand what matching is going on because it's very easy in Elixir to fall back into the sort of calm place where, well, it's equals, right? We just did an assignment. You did not. You did a match, right? So this is actually taken from some code I wrote with that man over there, right? Thanks, Bruce. I'm stealing your code. This is a standard pattern, right? We've all seen code like this. I mean, this prevents us from matching in something that we weren't expecting, right? This is an example of how matching protects us. If we pass in something that's not, like essentially, in this instance, the name of this module was Rover, right? It'll basically barf at us. And it's like, I'm not going to let you do that. How many people here have ever tracked down a bug because somebody passed the wrong data structure to you? Right? And think about sometimes what I hate is when they pass the wrong data structure that looks like it should be the right one. Like some JSON blob where you're like, why is this blowing up? Oh, it's ID underscore ID. What? Not ID? Well, okay, yeah, right? Elixir keeps us from doing that. Guards. Should be using guards, right? We want our functions to be explicit. And guards are one of the ways that we can actually be super explicit about this. Now, this was a test, but you guys are all pretty smart Erlang functional programmers. Anybody going to use this ATM? I can Vanna White it for you. Right? Are there any restrictions on what we can pass? And what can amount be? Anything. It could be nothing. Right? It could, God forbid, it could be a car list. I see some people have been there. Okay, right? Right? Bad. Right? We can actually fix that. And not only that, we can be explicit about what we expect that function to do. Like, basically, we just said, hey, you can't take out more than $1,000. And anybody who comes behind us actually can see that explicitly if they look in the code. And so if somebody tries to withdraw $1,000 from an ATM and it errors out, right? Not only do they get a better error, but they can go back to the code and be like, oh, I guess they meant to make sure that this thing never could take out more than $1,000, right? Much better argument, much better error, right? Side note, I actually find Elixir is one of the few languages that doesn't hate you in terms of its error messages. I wrote C++ and advanced templated C++ for a very long time. And if anybody has ever tried to debug a template, you don't. You just give up and basically delete everything and start typing it again and over again because nobody's going to find the missing angle bracket, right? Strings. This is where things can get a little hairy, right? Have anybody actually, generally speaking, ever run into problems with these, the differences between these, right? It's super important to know. Oh, you have? Exactly, because
Oh, right, I turned into
a car list, right? We need to just be aware that there are basically 3 different things that are sort of all kind of treated the same. So the rules are, you can usually ignore strings. There is, however, a caveat, which is the second rule, which is you can actually ignore strings right up until you can't ignore strings, right? So take a second to parse this. It's basically we put something as an emoji, and without going too much about UTF encodings and everything else, it's not going to do what you think it's going to do, right? That's the intent of telling you this slide, right? So we're basically, we have a string, it's got an emoji character in it, then we're going to put what the string is, we're going to put its length, byte size, what's the last character, and then we're going to get the code point operator on it, right? So the length is 7, but the number of bytes is 10. And if you understand anything about Unicode strings, you'll understand why that's different. Now, one of the places that this can bite you in the butt is imagine you're doing like a protocol buffer, or you're allocating something, you're sending something across the wire, you have a wire protocol. So, and you get a string, or what you think of as a string value. Is it? Is it really? Right? That's super important, especially when you start talking to things outside, because that's how you can actually either corrupt memory or cause crashes. Enumerate all the things. Oh, is it really? Actually, I am so sorry. Was it 35 minutes or 40 minutes?
35, we have a keynote.
10 minutes, got it. Well, then we'll skip to something else. Learn Erlang. Let me actually do one thing for you. Find the slide for you. I thought it was 40, man. Sorry about that. This is actually a straight 45-minute talk. Let me give you the stuff that you actually really need, right? Which is this. The resources are as follows. Remember, I'll send you these links. This is functional programming for the rest of us. That's actually a really good link to actually learn functional programming. This, the Elixir handbook, of course. This is Bruce's book. Seriously, if you're going to deploy a production Elixir app, read this book first. It's the best book on architecting Elixir apps I've ever seen. And I'm not just saying that because I learned how to write stuff from Bruce. Pragmatic Studio actually has some really great videos on this. You know, Bruce actually has a platform for learning Elixir and actually other languages. And finally, I'm going to tell you one other thing. Learn you some Haskell. Because Haskell will make you, I am the world's most terrible Haskell programmer, but it turns out by being a bad Haskell programmer, I'm actually a pretty good Elixir programmer. So unfortunately, that's time for me, and I will put this last thing. There's so much there that you guys need to learn. Just don't be afraid to dive in and do it. Thanks for your attention. And you can always get any of the slides or the resources from this talk by dropping me an email, all right? Thank you so much.
Wow, that was an excellent talk. Thank you very much.
Absolutely.
We may not have enough time for questions. If you'd like to if you have some questions, maybe stick around. Otherwise, we have our keynote starting in 10 minutes.
Perfect. Yeah. Come. Sure.
Yeah. Sure. Yeah. Absolutely. Does anyone have a question? Or we have time for one.
One question. No pressure. Not even like who was the metal band playing before like the slides came on? So, because that one's shorter and in bigger print, my full name doesn't fit. That's really, it literally was a font size. That was.
Yeah, so you were talking about what makes languages hard to learn or easier to learn.
Yeah.
How would you approach designing a language so it's easy to learn?
Ooh, interesting. That's the question is how would I approach designing a language so it's easy to learn? That is actually a great question because I tried designing languages for a while, like using Randall and Antler, and I actually found out that I am terrible at designing semantics of languages, and that designing a language is super hard. I don't know that I could. I don't know that I really could, because when you start looking at the affordances that you need to get a language, who are you designing it for? What's the purpose? All of those things play in. So to design a general purpose language is really hard. And in fact, I think that's one of the things that's kind of amazing about Elixir is you're talking about something that works everything from embedded systems all the way up to a web application or mobile applications at scale. And the language just works. That's kind of an amazing feat for me. So I don't know that I could, but that's a great question. I'll tell you when I launch my own language. Call a swear.
Easy to learn by whom, right?
Right.
There's some languages that are made for
Anyway,
specific kind of people.
so absolutely. All right, hey, I'm gonna be packing up. By all means, feel free to like track me down if you have other questions while I'm stuffing like crap into my bag. But thanks so much for coming, guys. Really appreciate it.